Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing general wave properties, paper 4, classwork for extended candidates only. We have question 3. We have a water wave here, passes through a gap. It's not water, it's not mentioned. Wave passes through a gap in a barrier. The wavelength of the wave is the same magnitude, same size, same value as the width of the gap. Okay? Tick one box here to indicate what happens. If we have the dimensions of the gap is the same as the wavelength of the wave, so diffraction takes place. Okay? The second part is very important. I will show you how to draw here the wave fronts of the wave in the shallow water where waves travel more slowly. Before drawing, to make sure this drawing is correct, you have to remember the wave equation. The wave speed is equal to wavelength times frequency. When the frequency is constant, what happens to the frequency, the wavelength and speed? In shallow water, you know that the water is moving more slowly, travels more slowly. So the speed decreased and the wavelength also decreased. So when you draw wavefronts, make sure that the wavefronts are close to each other so your drawing will be accurate. Number 1, the first step, you have to draw normal line to the boundary. I will draw 2 only. Okay. So this is the first normal to the boundary. Here. Normal to the boundary means at right angle, perpendicular, imaginary line just for construction line, and I will draw the direction of wave travel. What happens when water travels from deep to shallow water? The direction changes, it bends towards the normal. So this will be the new direction. This is not the blue line here, is not the wavefront. I'm just drawing how the direction will be changed. Try to draw them parallel to each other. Okay. Now I will draw wavefronts. Wavefronts should be perpendicular to the direction of wave travel. This one is perpendicular to the direction of wave travel. Is it clear, guys? So now you Now you can compare the wavelength. So in shallow water, what happens to the wavelength? The wavelength decreased. The wavelength is the distance between here wavefronts. This space is representing wavelength. If you compare it to the one in deep water, you will find that the wavelength decreased. So your diagram will be correct. The last part, the depth of the shallow water now changed so that the speed of the wave in shallow is 0.60 meter per second. The speed of the water wave in deep is 0.80 meter per second. So let's write down what is given for each case. So in shallow water, the speed is 0.60 meter per second. In deep water, the speed is 0.80 meter per second. Okay? Okay. Calculate the wavelength of the wave in shallow water. What do you know about deep? You know the speed and you know the wavelength for speed. You know wavelength for speed. Okay, but this wavelength in centimeters, so you have to check you have consistent units. In deep water, you have here the wavelength for deep water is 1.4 centimeters, which is equal to, from centimeters, you have to convert from centimeter to meters, so you have to divide by 100 or multiply by 10 to the power of -2. So it will be here 0.014 meters. Is it clear? Okay, but the wavelength here in shallow is not given, is required to find. We will start by the first part using wave equation. Since here the frequency will be the same, during refraction frequency is constant in deep and in shallow. So here the frequency is constant in deep or in shallow. So the speed here in deep is, you can rearrange to find the frequency first. So F is equal to speed divided by wavelength, which is 0.80 divided by 0.014. So the frequency will be 57.14 Hertz. Only the final answer should be rounded. Okay? For shallow region, this F will be the same, so you can substitute now again in the wave equation and you have to find the wavelength. Rearrange, so you have to substitute the speed for shallow one 0.60 meter per second and your answer. So the answer is 0.0 meters, which is 1.05 centimeters. Okay, check that units are consistent. So that's, we have hertz, here we have meter per second, here we converted the wavelength here in meters. Okay, so your answer will be 1.05 centimeters. Okay guys, we have another method, which is, you can say that the frequency in shallow will be the same as frequency in deep. If you arrange the equation, so you will write that the speed in shallow divided by wavelength in shallow will be equal to the speed in deep divided by wavelength in deep, what you have here is the speed in shallow is given, the speed in deep region is given, the wavelength in deep region is given, so you can find the wavelength in shallow region. It's another way to solve this problem. It's challenging and it's very important.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor.